Well, we're all set up, so we might as well go ahead and do another algorithmic variant. So which one shall we do next? Well, what if we assume we haven't done this? So that's our current state. Let's see what happens. What did we see in the last video and many of the exercises that you've done so far? In the end, it's a matter of coming up with what the state in step 6 is, what the state in step 7 is, and to then do a compare and contrast. If you think about it, this is again going to have to be an algorithm that goes from the top left to the bottom right. But now what? Okay, well, let's have a look. If we look at how the matrices are repartitioned, what you find is that the state that's in step 6 is that C0, C1, C2 is equal to A0, 0, B0 plus C0 hat. And then A bottom left is A10, A20 times B0 added to C1 hat, C2 hat. Okay. But you are now really good at doing partition matrix multiplication, and you recognize that this times that is the same as that times that for the top part and this times that for the bottom part. So we'll just go ahead and fill it in. Okay, then we go to step 7, and there we get that, okay, imagine moving these lines. I'm not actually going to do it now. What do we get? C0, C1, C2 is equal to A00, A01, A10, A11 times B0, B1. This is now A top left. This is now a B top. Added to C0, C1 hat. That is now C top hat. And then below it we get, let's see, A bottom left, but now A bottom left is A20, A21 times A times B top, which is B0, B1 plus C2 hat. All right? Then we recognize that because of symmetry, we really should compute with A10 transpose here. And then this all boils down to this times that plus this times that plus that. This times that plus this times that plus that. And for the bottom part, we get this times that plus this times that plus that. All right. So, what is then step 8? Well, we recognize that C0 already has this plus that in it, which we identify as this part right here. So all we need to do is take C0 and add to it A10 transpose times B1 plus C0. No hat there. C1 similarly should be updated. This is already in it. So all we need to do is do A1 1 times B1 added to C1. And finally, C2 should be updated with A21 B1 plus C2 for the same reasons. And there we have it. What kind of update is this? Well, that's this matrix transposed times B1. And if you think about it, let's see. Let's erase this so we give ourselves some room. This operation here is now a matrix that looks like that. That's A10 transpose times B1 added to C0, which in general is kind of a big rectangular matrix. This right here is something we saw before. It's a update of, let's see, it's a symmetric matrix, small block times something long and skinny added to something long and skinny. And then this final one, if you think about it, is exactly this shape again, except now it comes from A21, multiplied by, again, B1, but now added to C2, which in general is a rectangular shape. Okay? So this we recognize as what we call a rank K update. And we notice now that we have a big part of the computation being cast in terms of two separate rank K updates. And again, in the enrichment, we're going to find out that rank K update is our friend. Right, and that's it.